Okay, so what we're going to talk about in this slide is how we can add, subtract, multiply, and divide these complex numbers. So we had z1, which was 3 plus 4j, which is also 5 angle 53.1. And then our second complex number was negative 5 plus 12j, which is 13 angle 112.6. Now, if I wanted to add these complex numbers, it is going to be easiest to just add them in their rectangular way. And all you have to do is combine like terms, and you get the answer negative 2 plus 16j. And also, if you're subtracting, no problem, you do the same thing as we just did. The only difference is you have a negative side to distribute. And regardless, I should get 8 minus 8j here. Now, when it comes to multiplying or dividing, there's going to be a little bit of an issue. You certainly can multiply and divide with the complex numbers written in the rectangular form, but if you were going to do it this way, you would have to FOIL. And then once you FOIL, you square your j, and once you square your j, you get negative 1, and then you combine your like terms, and it's kind of a pain. And it turns out, if you use this phasor notation, our lives are going to be much easier when you're multiplying these things. And how it works is you take the front numbers and you multiply them. So 5 times 13 is 65. And then for the angles, you actually just have to add them. So 112.6 plus 53 is 165.7. And you can do that without foiling, without expanding out, without doing any of that work. You get the answer. And similarly, if you want to divide two complex numbers, you may or may not remember you have to multiply top and bottom by the conjugate. And then you FOIL top and bottom out. You do a bunch of simplifying. It's a real pain. Or what we can do is we can divide here. And the way you divide when they're in polar notation is you go ahead and divide the front numbers. 13 divided by 5 is going to be 2.6. And then you just have to subtract the angles. And 112.6 minus 53.1 is 59.5. And so basically it comes down to, if you're adding or subtracting, it's better to leave it in rectangular form. If you're multiplying or dividing, it's better to have it in polar form. But you just use whichever one is most convenient in a given problem. And really quickly, before I go on to the next slide, I wanted to kind of look at orthogonality really quickly again. This e to the j theta thing here. So when I write down 5 angle 53.1, I can also mathematically write it down as 5 e to the j 53.1 degrees. Now you could think of this as just an alternate way of writing the phasor, and that's perfectly fine. But the reason why we do that is because of Euler's identity. It turns out mathematically it's the same thing. And this is why our multiplying and dividing rules work. Because if you have two things with e in them, you know from your algebra classes that you're supposed to add those two exponents. And so if I have e to the j theta 1 times e to the j theta 2, it ends up just by adding the angle. This is where the angle addition rule comes from. And similarly, when you're dividing, you subtract the angles. So this is the reason why we like using e in this fashion, but you really could get by without using e and just using the phasor notation. It doesn't actually matter that much. It works out the same.